All right, so next up, we're going to take a look at conformers. So conformers, it's the same molecule. It's just rotated in a different 3D shape. So you can think of like one conformer as you standing up, and then maybe another conformer as you standing down. So we'll take a look at the simplest one, ethane. Right, and so remember there's 3 hydrogens here. And we can draw the Lewis structure of this compound and think about its shape as well. So we've got a carbon, and then we've got a hydrogen kind of sticking out, hydrogen going into the back of the board, and then a hydrogen over here. And then this other side we could draw as the same way or as opposites. But both of these carbons are tetrahedral. And so for these things that are called Newman projections, what we're going to do is we're going to pretend that this is our eye right here, right? So that's your eye. And you're going to stare down this bond angle. You're going to stare straight down this bond angle. And so the first thing that you're going to see is this carbon right here. And so this carbon is just going to be in the center here. And then you'll see a hydrogen kind of poking to the upper right and the upper left, right? So hydrogen, hydrogen, and then one going down, right? If you picture what that would look like, it looks something like that. So that's how we draw the front carbon. And then there'd be a carbon in the back, right? This carbon in the back, but you wouldn't actually see this carbon. It'd actually be eclipsed by the frontward carbon. And so the way we draw that is just a circle, right? This represents the carbon in the back. And then you can draw in the hydrogens that are poking back there. And this is what's called a Newman projection. And so if we think about it, it makes sense. This hydrogen right here is not eclipsed with any of these hydrogens, right? And you can see these hydrogens are not over top of one another. But we can rotate about this bond. And so we could draw another conformer of this ethane molecule. And in this conformer, we'll draw both sides of the hydrogens or both sides of the carbons as the same. And then if you think of looking down this bond, these hydrogens are going to overlap or eclipse one another. So here's how we draw that. Right, you'd see a hydrogen poking straight up, one to the bottom left, one to the bottom right. And then there'd be an eclipsed carbon in the background. And then these hydrogens would overlap directly with one another. We don't draw them directly overlapping, just because that would be hard to see. We draw them right next to each other. Right next to each other. And so these are the 2 different conformers of ethane, or the 2 main conformers. This one on the left is called staggered. And that's because the hydrogens are not eclipsing one another. Whereas the one on the right is called the eclipsed conformer. Because the hydrogens are eclipsing one another, right? They're right on top of one another looking at it from this angle. And so in general, the staggered conformer is lower in energy. And the eclipsed conformer is higher in energy. And the reason for this is actually a little bit more complicated than you might think. So we have these hydrogens here. And in this case, hydrogen is actually pretty small. So it's not due to the size of the hydrogen, but it's actually due to these kinds of electrons in these bonds repelling one another. And it's actually a little bit more complicated, but we'll just stick with that simplified explanation. And this is called torsional strain. Right? The fact that these bonds like to be far apart from one another. And so we have one that's lower in energy, one that's higher in energy. So we could draw a little energy diagram for this. This is the one out of your book. And you can see what we're doing is rotating about that central carbon-carbon bond. So we're moving this back hydrogen around the molecule. And you can tell that all of the eclipsed conformers, right? This one's eclipsed, this one's eclipsed, this one's eclipsed, and then this one's eclipsed, are all higher in energy, while all the staggered conformers are lower in energy. And so at room temperature, ethane is free to rotate. It can rotate about all of this stuff. But at lower and lower temperatures, the energy barrier becomes high relative to the amount of available energy, and then it can't rotate. And again, the reason for this is torsional strain. Later on, we'll learn about steric strain.